All right, cool. So like I said, my name is Rhodey. I'm from Applause. We provide testing, feedback, and research. This talk is kind of cool because I didn't expect to see another DSL, but the first talk, actually, I would argue, Glance was a little bit close to a domain-specific language. But really quick, what is a DSL? A DSL is a computer language specialized to a particular domain. The easy example is saying SQL. So everybody knows what SQL is. It's not quite like a programming language. It's not quite a scripting language. It's this like specific language that can do only one thing. It really just like queries data, and so it's called a domain-specific language. So we do like a lot of kind of R&D and like investigating new possible products. Put out a few POCs and in Applause. And one thing we just wanted to investigate was like what would it be to do like a DSL for Appium. Like how good could it look? Interesting enough, there's already a DSL for Selenium if you use Scala. But if you look at this, it's pretty readable, but it's not really the level of readability we wanted to get to. So we wanted to go like further from here. And what we ended up with is kind of like this over here. So this is the first iteration. We targeted Scala as a language because Scala has this neat thing called dot notation, which basically makes you can go from here to here, basically not providing the dots and the parens, and it's syntactically, and it executes the same. So that's a reason that Scala is a really good language to target for DSLs. But what we have here is these first two DSLs are actually what's called an internal DSL, which means all the parsing is done, all the execution is done by the Scala compiler. You can't actually just like send this over the wire and execute it. So it's called an internal DSL, but that would mean that if we wanted users to write these, we would have to have them write Scala files, send us the Scala files, compile them, and that's kind of like security annoying or whatever. So what we really want is an external DSL. Something where basically we can pass a string, across an API or like at a command line or whatever. The string can come from anywhere. We can parse that, and then we can execute it. So we don't have too long here, so I'm just going to let these tests run while I talk. I'm going to run 4 different tests. 3 of them run in Scala. 1 of them runs in Java. 2 of them run in Java. The cool thing about Scala is it's on the JVM. Most of our stack is in Java, so we can use that in Java. And I'm just going to kind of give a shout out here to the main tools that we used. Let's just show that the tests are running. Here we go. It's zoomed in, so it's mad at me. But the cool part about this is we choose to use a lot of open source libraries. A lot of this is actually just wrapping Appium with a lot of open source libraries. The first one that's important is FastParse. It's a Scala library. It lets you parse strings very easily. So this is just an example. Like I can change this to 6 and updates on the fly. The entire parser for this syntax right here is literally defined in one file. It's 104 lines. It's pretty great. Additionally, we use Scala.js, which means that now this parser doesn't only work in Java. We can use that from Scala very easily. We can utilize it from Java very easily, and also we can utilize it from the browser. So this is a really, really ugly demo. I worked a lot of time in the back end. I didn't work a lot of time in the front end of this. Again, this is proof of concept. But you can see, let me just type in, you saw there was like an example. The easiest action there is sleep. So I'll just start typing in sleep. And you see it expects a for duration or until displayed because I can sleep until an element is displayed, or for duration, I'll type in 4. It expects a number or a count, which means I can type in 1, or I can actually type in a number. Wants a unit, milliseconds, seconds, or minutes. And at that point, it's actually, you can see that this basically means that it's been able to parse the string out into what's called an abstract source tree. And then the next point is that we can go from the AST, we can do what's called walking the AST, which basically creates execution plan and then execute it. And the cool thing is that since this was done in Scala with the help of Scala.js, the entire project is basically, most of the runtime, all the parsing is written in this shared directory here. So we have one source of code for 2 different platforms, 3 different languages. And I can actually, the runtime is actually implemented too in Scala, which transpiles to Scala.js, so I can actually execute this very simple script in JavaScript. And you can see, starts it, it's going to sleep for 5 seconds, and then it's going to pass. Just to show you, I can't do any fancy stuff like clicking because in Scala.js these are the interfaces I created for myself, Appium element, Appium driver. I didn't actually implement click, I didn't implement send keys, because right now the only drivers you get for Appium or for Selenium that work in JavaScript don't actually work in the browser. They still have to use Node because they use the request package, etc. But you can imagine if we implemented click, send keys, open session, and find elements by using Ajax, then we could actually execute Appium tests in the browser. So that's the talk. Hopefully we'll open sources eventually, but the 2 projects you can definitely use are FastParse, Scala.js. Thanks.